So in this video, I will be discussing this lab, Intro to the Mole Concept. In this lab, you will be further cementing what you've been learning in lecture about moles, molar mass, what the connection and relationship between both of those are, and how that is related to elements. And you will take some measurements on different elements and calculate moles. So I think this lab is a really good learning activity to really understand moles and how it basically is just like a dozen. That's what really moles are. It's just a chemist's dozen. And it's just a way to simplify really large numbers of like atoms or molecules or anything like that. So we have two parts in this lab. How much is a mole and how many moles is that? So first we're learning what a mole is. And here you can see we have our video player, and you have two different toggles here, two different buttons you can press, element and moles. So for element, you can change between different elements. There's, I believe, a total of 8, and then for moles you have up to 5. So for each of these you can look at the video for 1 mole, 2 mole, 3 mole, 4 and 5. So the point of having these different options and different videos available is that you are going to graph some data. You are going to first record data and then graph it. So luckily you have a very good example of what I'm looking for regarding this lab. So you will be showing the number of moles. You have the number of moles here, right? There's 5. You are recording the mass for each corresponding mole. So for, let's say, element 1, here it's telling you element 1, right? You got to show the number of moles to the mass, right? So you're going to record element 1 here. So I would replace this with element 1. That's it. Everything else is already filled in. And then you are going to open up element 1, click mole 1, load it, and watch it. And it's going to weigh the mass, and you are going to enter that mass right there. You're going to do the same thing with 2 moles, 3 moles, 4, and 5. So that's what you will enter here, record there. Now, using that information, you will show a line. So this is already filled in. So these lines should already populate once you enter that data. So that's the easy. So once you get done with that, your line will show up, and you will use the fit tool to find the slope. The slope, as always, shows here, and the slope is your value a. So remember, y equals mx plus b. That's essentially the line, the equation that you have here. Y equals mx plus b. The m is always your slope. In our case, we're just calling it a little bit differently. It just has a different label, but it's really the same thing. So your a is the slope. So that value you are going to enter right here. Next, you are going to there's just some more follow-up questions. So identify the units. So I'm not gonna spoil that for you. And then there's a good way to describe how many grams per mole. And basically, you're just describing the ratio. So how many grams per 1 mole? So you are going to identify the statement that matches your graph. And from that information, you are going to consider what the molar mass is. And luckily for you, what you found in the slope is essentially the molar mass. Now, you are going to return to your data table, and then you are going to work on whichever element you are given right here. In this case, it's number 6. And you're going to do the exact same thing all over except for that element. And again, follow-up questions regarding that same element. It's basically the same exact process except for a different element. And then you are going to compare whether you have the same element or not. If the molar masses are identical, it's the same element. But if they are different, you have 2 different elements. So the molar mass is very related to the atomic mass. As stated here, it's almost exactly the same thing. Molar mass, the unit is grams per mole, versus atomic mass, it's atomic mass unit, AMU. But they are equal to each other. So 1 gram per mole equals 1 AMU. So from the molar mass that you identify in the previous questions, you are going to identify the element. So you can use your periodic table and find whichever mass on the periodic table, in other words, the atomic mass, matches your molar mass, and those are your elements, and you're going to enter those right here. And then just some follow-up, identify atomic number. So here we are recalling what atomic number is. So again, not going to spoil that, but I don't know why that just did that. But you are going to use that previous background knowledge to identify those. So now we are relating what molar mass is and how that relates to atomic mass. So if you found, that element 1 has an XYZ, whatever number you happen to get, grams per mole. If you were comparing the two, identify which atom has a larger mass, which element has atoms with more mass. In other words, which one, when you look at the atomic mass, right? Because atomic mass, you are counting and adding up the mass of protons and the mass of neutrons. That's for an individual atom, right? For moles, you are determining the mass for 1 mole of those atoms. So it's like saying, how much does 1 donut weigh versus a dozen donut, right? And for us, since they are different units, they end up being the same. Okay, so the number ends up being the same, right? So it's like saying, okay, I have 1 dozen, all right, I have 1 donut. So the number is the same. So here, that's how you relate the two. Your molar mass is your atomic mass. So based off of that, you can tell which one's bigger, which one has more mass. And then you're going to lock your section once you are confident and done with section 1. And you're going to head over to part 2. So in part 2, you are calculating moles. So in part 1, for example, this is a different combination, right? Every combination will be different based on whenever it's algorithmic. So everybody will have a different combination of 2 elements. But here we found the mass of element 3 and 6. So how can we use this value to determine the number of moles? So we are going to measure the mass. So very simple, straightforward. Select trial and then select the element, measure the mass. So I know you got that. Now you have to identify the molar mass. So you can refer back to the information that you learned in part 1. So you should still be working with the same elements. So you will be using information from part 1. So using that, you can continue on and think about this. So question 3 is a very comparative answer, right? You can compare the information you learned in part 1, and the reason for that is because it's asking, determine if the sample has more or less than 1 mole of, in this case, element 3. Enter 1 for less, enter 2 for equal, enter 3 for more. Now, how do you compare? So in part 1, you had the number of moles, the exact number of moles for every element. So you know that for element 1, 3 moles, for element 1, 3 moles, it's a certain weight, right? It's whatever it happens to be. It's, let's see, once they finish, it happens to be 81 grams or 80.9, right? So if you happen to have less than that, you can compare, right? So if on, trial, whichever trial you happen to be looking at, if it has less, you will know, you can just compare from that, right? So you can also calculate the number of moles using your molar mass that you determined and the mass that you measure here. So here I just have a random trial, right? I have element 1, trial 4. We are looking at how much mass we have. It's 90.39. The way that you convert it to moles is you are going to take convert from mass to moles. This is what we do. We will be taking our mass and setting up so that we cancel out mass and we end up with moles. So this concept comes from whenever you learned about dimensional analysis a while ago. So let's say I have 10 grams, I'm just picking an element, of magnesium. The way that I would convert to moles is I would have to go to the periodic table and I look up the molar mass, and whatever it happens to be, I'm going to set it up. So the mass part is going to go here. The mass, in other words, the units will be grams mg, and then the mole part will be up here. So I'm highlighting this because that's not actually what goes there. I'm going to show you a more accurate example in just a second. And then what you typically write is moles mg. So your mass mg would cancel out and you would multiply. Basically, it's always 1. This part right here is what changes. So this is always dependent on the element. So I'm going to show you a better example, an actual example, and that would be 230 grams of sodium. How do I convert this to moles of sodium? So if I go to the periodic table, I'm going to find that the molar mass of sodium, so I'm just abbreviating that big M, molar mass, and then the symbol sodium, is about 23 grams per mole. So anytime you have a unit like this, grams divided by moles, what you can do is split it up. You can make it look like a unit conversion equation. So I can split this up into 23 grams Na per 1 mole Na. So that's how that would look. So this is my unit conversion equation. And you know that anytime we have a unit conversion equation, we can set it up in whichever way we need to cancel out whatever we want to get rid of. So in this case, we would want to get rid of the grams Na. So what I'm going to do is put the 23 grams Na at the bottom and the 1 mole at the top. And grams Na cancels out, and this ends up giving me 10 moles. So that's how you actually calculate this out. So you might have to do some work on the side to complete your calculations, and that's completely fine. Just make sure to be neat with taking notes and labeling so that you don't get confused on the different elements. So just keep that in mind. You do have your molar masses, and then you do have your masses, so you can just do exactly what we did just now and set that up and calculate moles. And then you would be doing about the same thing, but for a different trial and element. Yeah, so this would just be, you would just be repeating this, and that would be the rest of these questions. So it's just getting you to practice these same calculations so that you kind of get the hang of them. Just be aware, don't be stressed out that this is something you don't understand. Sometimes it just takes some time to figure it out. So go with the flow of the lab. It's meant to be kind of repetitive so that you learn it that way. So thank you for watching. Please let me know if you have any questions at all, and I will try my best to help you.